You are looking at lesson 14 for week 5. If you don't have a graphing calculator near you, you might want to grab it. And if you haven't printed it, rather, these notes off, you should do that. These are what we call closed notes or fill in the blank notes. You could just write them on your own too if you don't have a printer. I realize that. Some of you don't. So anyway, our target today, and if you've forgotten, I hope not, I will be able to predict features of a parabola based on its equation, right? So what do the equations look like? Well, we've got our standard form here, right? I'm going to be doing some color coding with those things that are not x and y, okay? So coefficients and constants, right? And I just want to remind you, though, that the parent function for all of this is if a were 1, b was 0, you wouldn't have that x, and c was also 0. So the most basic kind of quadratic function that we can have is, I don't know if you can see that, just going to look like that, right? And if we were plugging in 0 squared is 0, and 1 squared is 1, and 2 squared is 4, and 3 squared is 9, right? So that's our most basic or parent function. So we want to keep that in the back of our mind because everything that we talk about is relative to that parent function, okay? Okay, so let's look up the coefficient for x squared, or a. If a is positive, right, then what should we know about the parabola? It opens up, and that means it looks like this. So the opening of the parabola is up like that, okay? So obviously then if it's negative, it's going to open. We sometimes will say upward and downward, but obviously I didn't leave myself room for that, so it opens down. So down is the frown. Okay, so we're looking for positive or negative to tell us the direction of the parabola. And then as far as the number goes, if that number is between -1 and 1, or a fraction, right, then it is wide. And if it is greater than 1 or less than -1, then we say it is narrow. So if we just play around with that for a minute, you're going to see the camera if I do that. Let me move it up a little bit. So let's say I do a negative x squared. And grab that. All right. How about we do a 2x squared then? And we would predict, since it's greater than 1, it's going to be skinnier. Yep, it's within that parent graph. And how about if we did 1/4? 1/4 x squared. So 1 divided by 4 x squared. Right. A little lighter on our, it's using purple, so it's harder to see. But that one's much wider, right? Okay, so the coefficient of a then is going to tell us about its shape and its direction, okay? Okay, let's skip on then to coefficient of x, or b, that b value. B value is going to show us any horizontal translation. Now translation, you know, hopefully from work from last year, translation is a slide. So it's going to slide it left or right. Okay, so if you need to do that, you know, right and left or right, please do that. Okay. It also is going to show us the axes of symmetry. Now it's not going to show it, but it'll give us the information we need to find it. Okay, now the axis of symmetry is just the x value of the vertex. Right. So in this case, with our parent graph, there was no b value, so the axis symmetry was just the y axis, right? Okay, so let's say we go back in here and let's go over here and add 2x. See what happens. Oh, look at that. So it shifted it to the left, right? I don't know if it'll let me interrupt it because we don't necessarily need all these other ones now that we were using to compare A. So I'm going to go back in there and take those out. So if you give me a second. Okay. So what if we did x squared about minus 4x? So we know it's going to shift it left or right. There we go. Now notice it didn't change the shape of it because it has the same A value, right? So it's the same, width. It's still opening up. Okay. We will learn a little more about those specifics when we start graphing, all right? Okay, and now let's just talk about the last thing, which is our constant, or C, or whatever it is we're adding or subtracting, right? That, if you remember, in standard form, is the y-intercept. Okay, so if you look at the graph that we were just looking at, they both still have a y-intercept of 0, don't they? That's why that had to shift down to keep the same shape. And it also will show us any, if you can think about this being horizontal, well, we're going to get vertical translation. And vertical translations then are up or down. And that makes sense, I think, for you if you recognize it's about the y-intercept, right? So up, down. Okay, so let's give it a try in here. How about we change, we'll take this one out and do, how about just, let's just come up here and just add 2. Okay. So we know what it should look like if it was a parent graph. So see how it just slid the y-intercept up? If we had a different one that was, how about we do a bunch of 2's? How about 2x squared and 2x and 2? Okay, a little bit more narrow, a little bit to the left, and a little bit further down, right? Oh no, the the y-intercept is the same. Different kind of stretch. We call it that we've either done a compression or a stretch when we change that A value. We're again going to talk about that a lot when we get into some graphing soon, okay? Okay, last thing I want us to add to our notes here is, well, if we're talking about it's the x value of the vertex up here, well, what is that vertex, right? Okay, well, we just said if you took the opposite of b over 2a, okay, that is going to be your axis of symmetry. And that's going to be the x value, okay, of the vertex. So how do we get the y value? Well, it's f of x. We plug in, right, whatever that number is, right? So whatever the x value is, we plug it in, we find f of x, or y, the y value. Okay. So it might be something, I don't know if we have room up here, the axis of symmetry, maybe add that up here as well. The opposite of b over 2a. Ooh. Is our axis of symmetry, okay? Okay, so what you're going to have to do is, based on certain equations, just like we were just showing with the graphing calculator, is kind of determine what is that parabola going to look like. Does it open up? Does it open down? Is it translated left or right or up or down? Is it narrow? Is it wide? And you'll have to do this in a Schoology kind of quiz. I prefer that you try to push yourself to know that without relying on your graphing calculator. We were using it today just so you can get a feel for how it changes it when we add those values, okay? All right, good luck with that.